When do we usually use the special product of binomial and trinomial, where we expect to get the either the sum of two cubes or the difference of two cubes? So let's look into this case. The first factors that we have here is x plus y multiplied by x squared minus xy plus y squared, and it results to the product of the sum of two cubes, which are x cubed plus y cubed. And in the second case, we actually have x minus y multiplied by the quantity of x squared plus xy plus y squared, and this results to the difference of two cubes. So x cubed minus y cubed. When does this situation or case happen? Remember, this is only possible once we have a binomial and we are multiplying this binomial by the square of the first term in that binomial, and the differ or minus or the negative of the product of the first term and the second term. Like in this case, you have x as your first term and the y being the second term. When you multiply x and y, the answer that we will be getting there is equal to a positive xy, but the negative of that will result to negative xy. And the third term is the square of your second term, which is now y raised to the second power. So basically here, we have now the x cubed plus y cubed. Actually, we can make use or we can prove that by making use of our long process of multiplying with your polynomial. So if we happen to have this kind of problem, you can have x squared minus xy plus y squared, and we can multiply the x plus y with this whole thing. So we have x plus y. So making use of your rules in here, we can simply just distribute. So we will first distribute now our x to all the different terms in your dividend. So x multiplied by x squared, you will be getting x raised to the third power. And then multiplying x with the negative xy, that will result to x squared y. And we have x with the y raised to the second power, or y squared, then you have a positive xy squared. Now, next thing is we are going to distribute now y. This time, we have a positive y being distributed to your dividend. So y multiplied by x squared is x squared y. So it will just be proper that we write that directly below the one which is similar to it. So x squared y, which happens to be positive, so we don't need to write that. And we have y multiplied by negative xy, so the answer that we will be getting there is negative xy squared. So again, we have to write it below the term which is similar to it, which is now the positive x or xy squared. So we have it there. And you have y multiplied by y raised to the second power. So the answer that we will be getting there is positive y raised to the third power. So if you are going to add this, these are now the partial products. If you are going to combine them, you will notice that the negative x squared y, the positive x squared y, this will automatically cancel each other. Okay, and also the xy squared with the negative xy squared. So what is left now is simply the x raised to 3 positive y raised to 3, which is actually now the sum of two cubes. So what does this suggest? If you can observe that in your given binomial, we have, again, a first term and a second term, and you are multiplying this by the square of the first term. So we have x multiplied by itself, and then y multiplied by itself also, so y squared, and that the middle term is the negative of the product of the first and the second. Therefore, we have the sum of two cubes. And if you have the difference of two cubes, it will just be a change in the sign. So again, you have here x minus y. Okay, the square of your x is x squared. The negative of the product of the x and y here. So x multiplied by the negative y is negative xy, but you get the negative of that, so that is positive xy. And then the square of your negative y is equal to y squared. And the result, if you are going to multiply this, you have the difference of two cubes, x cubed minus y cubed. So how do we apply that? So if you have a certain problem which is similar to this, you have 2x minus 4, or the quantity of 2x minus 4 multiplied by the quantity of 4x squared plus 8x plus 16. Let's investigate first. So we have the first term here is 2x. Is the first term in your trinomial the square, okay, of your first term? So 2x times 2x is equal to 4x squared, so that one is satisfied. Now we have the last term, which happens to be 16. So negative 4 multiplied by negative 4 is equal to positive 16. So that is satisfied. And if you are going to multiply 2x and negative 4, the answer is a negative 8x. But the negative of that is positive 8x. So therefore, we can make use of the rule which states that you can find for it by simply getting the cube of the first term and subtract it to the cube of the second term. So 2x raised, or quantity to the third power, will simply mean 8x raised to the third power. And then the operation is a difference. We have negative 4 now. Okay, negative 4, and that is raised to the third power. So the answer is negative 64. Okay, let's have the second problem. You have now 3x plus 7y, and that is being multiplied by 9x squared minus 21xy plus 49y squared. Okay, again, to minimize the time, we just try to look into that condition. So 3x, if you multiply it by itself, you have 9x squared. You have here 7y, you multiply it by itself, it is now 49y squared. Now, if you get the product of 3x and 7y, that results to 21xy, but the negative of that is the negative 21xy. Therefore, we can just find for the answer. That means you have to get the cube of the first term. So 3 cube is 27. And x cube is, of course, x raised to the third power. And for us to get the last term, you have positive 7y raised to the third power. So 7 times 7 times 7. So that is 49 times 7. That is 343. So we have plus 343. And there is another variable that is involved, which is y. We just have to get that. And of course, raise it also to the third power. Again, this one is only limited with the following condition. When you have x plus y, the multiplier should be x squared minus xy plus y squared for you to have x cubed plus y cubed. In the same manner that if you have x minus y, it has to be multiplied only by the square of your first term, the negative of the product of the first and the second, and the square of the second term to arrive at an answer, which is the difference between your cubes, x cubed minus y cubed.